Do you remember how to make all the little baby slopes? How do you make the baby slopes? Okay, so you kind of like make a little T-chart of X and Y. I can hear that on the recording. It's all over the recording. No, get it open so we can be done with that package. Open it. Do you need it? Do you need help? You're not strong enough? Let's go. Open the package, son. Could be. You never know. You think? A little bit of genetics going on? All right. So let's do, how about 1, 1? If you plug in 1, 1, if you get a slope field question, it'll have these little dots, and those are the only dots you do. 1, 1, what would that be? 2. So you need to draw something with a slope of 2, which is steeper than a slope of 1. So you could do that thing where we kind of guided ourselves by up 2 over 1, but it'd be something that looks like that. You notice that the origin does not have a dot. It only looks like there's, it says there's 8 of them. One, looks like one's over here. Let's try that one. 2, 0. 2, 0 is going to be what? 1/2. So that would be kind of slanted like that. So you could do that, right? You can go through and draw that? Okay. So that's your review of slope fields. Okay. What I'm more concerned about is on the FRQ, on the mock, when you had to do a solution to the differential equation, and a lot of you just created some brand new math that I'd never seen before. All right. So you got something that looked like this. And on your mock, I wrote sep, int, because that's what you were supposed to have done. Separate, separate, integrate, integrate. So when you get a situation like this, you could cross multiply, but you need the y's on one side and the x's on the other side. So to do that, if you cross multiplied, or just did it in your head, you should end up with dy over 1 plus y equals dx over x. The other way, like you switch, the dy and dx's have to be in a numerator. You cannot integrate them when they're in the denominator, so they have to be in a numerator, so that's kind of how you know which way to go. This is the one where this is worth 5 points. So this was worth 5 points on the mock. This is 1 for the separating. They gave a point for integrating each side. Then the plus c was a point, and the initial condition is a point. Remember how we talked about how you can easily earn those points? So if you didn't know what to do, that was 0 out of 5 automatically. And so that's why that question hurt a lot of people. All right, how do you integrate each side here? Okay, natural log 1 plus y. Don't forget your absolute values. Equals natural log x. Okay, your plus c has to go on that line right there, because that's where the integration occurred. Now what do you do? You could E up or you could plug in. Either way. So I think it's easier to go ahead and find c using the condition of negative 1, 1. So that would be the natural log of 2 is equal to the natural log of the absolute value of 1, but the natural log of 1 is 0. So therefore, c is equal to the natural log of 2. And there you've earned 4 of the 5 points, even if you don't know how to solve. All right, so this is where you go to solve for y. Oop, I have a c value. Now we E up. Okay, so if you E up, now you could go ahead and drop your absolute values. Do you know why? Actually, let me think about this. Let me look at the point I was given. Oh, I was given negative 1, 1. Nope, not dropping them yet. Yeah, I can for there. Because how do you e up this side? E to the x times e to the natural log of 2. Do I remember how to break that apart correctly? Oh, it's ln. All right, let me back up here. I was worried about that absolute value. All right, I'm e upping. Oh, so that's just x times 2. Okay. Yes. Now, why is it time? Because when you. Yeah. Okay. So when you drop the absolute values, you have to consider a what situation? A plus or minus situation. So you have to consider a plus or minus 2x. It's the plus or minus is on the x, but really is just going to go in front of that whole thing. So, I mean, you could go ahead and solve for y and say y is equal to plus or minus 2x plus 1. But you now have to pick whether you're going to use the plus or the minus 1. Ooh. It's not my fault. Now, how do you pick? The point negative 1, 1 is how you're picking. So you plug in x value. You plug in the x value of negative 1 here, subtract 1, and which of those is going to give you, so you want the negative? There's another reason you would have known it was negative had you finished out this slope chart up here. I wonder what's going to happen right here on that little dot. What's going to happen if I choose negative 1, 1? Oh, gosh, on Friday, what is going on? That's why. Okay. That dot. Negative 1, 1. What would you get with negative 1, 1? Negative 2. Oh, well, guess what? It's a slope of negative 2. What are you supposed to have? Slope of negative 2. So you would have picked the negative. So maybe that you could have used that idea also. Okay? Sir. How would you have known it was a line versus, say, a quadratic or something? The reason I say that is because on the next one, like it doesn't turn out to be a line. So you don't know what it's going to turn out to be. So status domain. X can be everything but, yes, because every X can be everything but 0. Yeah. Yep. X cannot equal 0. Yep. Okay, so I think what this leads to is, how did you know it was subset to begin with? Because I think if you had known that on the mock, if some of you would have had that, like, if I would have said, oh, you subset, then maybe some of you would have got more points on it, you know? So how do you know it's one of those questions? Solution to the differential equation. You're always given an initial condition. It's wanting a y equals, and the only way to make this y equals, you can't just integrate x's and y's. You have to integrate them separately. So maybe that idea of doing them separately. So if you separate this guy, you're going to have what is that going to be? Can y'all cross multiply in your head? dy over y equals e to the 3x dx. All right. What would you get if you integrated that? Okay, natural log of y equals 1/3 e to the 3x plus c. All right, and then y'all can finish that out. Okay? Anything I'm not doing today is just for you to practice with. I'm just trying to I'm trying to review as many topics with you as I can to get you ready. All right, and then the next piece is a tangent line, but you have to get that done first. All right, so go to your next one. This is a SEP problem in disguise. So just read that question. 30 feet high. That's the initial condition. The height is given by this equation. So you have this equation here. The height of the water satisfies this differential. Height is measured in feet and T is measured in months. So that's a feet per month equation. All right, so question A says use the tangent line to approximate the graph. So you would have to find a tangent line, okay? So that's just a tangent line. What do you need for a tangent line? Slope and a point. Well, how do you find the slope? Use the tangent line at 0 to approximate the height after 1.5. So you need to do the first situation, like don't do the 1.5 yet, do the height at 0. Well, don't you need a slope? Slope is your dH dt, right? So you need dH dt at time equals 0. But look at this equation. There's no time here. That's a height, right? But what's height? Time equals 0 means a height of what? 30, because what is the initial height? 30. So you're really doing at height equals 30. So that's how you come up with your tangent line. That's kind of not the part that I'm worried about. I'm worried about part B, which showed up on the mock. And it wasn't a damn problem, okay? But it said find this. So what is that? Second derivative. Okay, so basically you need to find the second derivative of that. Now, okay, so let's do that. Do you want to distribute that 112 first or anything, or are you good? No? Okay, so d squared h. I don't really like that notation, but whatever. Okay, so what is the derivative? 112? Because isn't this really 112h? Okay, so the derivative of 112h is 112 dH dt. Why did I tag it? Because I'm taking a derivative of h with respect to time. Okay, so it's 1/12 dH dt, which is fantastic, but that's the wrong answer. Because you didn't answer the question. The question said find it in terms of h. You found it in terms of dH dt. So you have to plug dH dt's equation back here, and then it's accurate. So it's like, oh, second derivative, I can do it, right? But make sure you follow through with the directions. It says find it in terms of h. This is not in terms of h. And so when this question showed up on the mock that year, there were like next to none that got this part right, because nobody realized that they had to do this. Now, where have you seen this before? When I've asked for a dy dt in terms of x and y. I've tried to keep putting those questions like in terms of x and y, trying to get you to replace your dy dx. Now, this is the second derivative, correct? Okay, so the second derivative tells you about concavity. And so when you plug something in here and it's concave up, then where is your approximation line? Or if something's concave up, this is going to be a what? A minimum, and all your approximations will be under it. If that second derivative is negative, then your concave down, that's a max, and all your approximations that you have are going to be above it. And that's how you determine when you have over and under approximations on a second derivative. If it's concave down, your approximation would have had to be above it, because your tangent line would have, so it's a over approximation. Well, there's more to do on this problem, right? So I was just in general saying, what happens if you're concave up versus concave down? Is that okay, Josh? Okay. Okay. Then what happened on a question like this? Because see, this is not just normal x's and y's, and this is why this can throw people off. Look at this. Find the particular solution to the differential equation with the initial condition. What is that sounding like? That's a sep int question right there. So it's wanting you to come up with a height equation. Instead of a y equals equation, yours is going to be a height equation. If you need to go off to the side and switch all the variables to x's and y's to make yourself happy, that's fine. Just go put them back when you're done. But if you were just to start this problem, separating the variables, what would that look like? H minus 10. I would probably leave that 1/12 over there with the dt because it just keeps that natural log a little bit cleaner over here. Sir? Yeah, because it says right before that, it says use your answer in part A. So yes, you need part A to go to finish out part B. Correct. All right, so you could solve that, right? You could keep going on that. That's going to be a sep problem right there. Okay. That's one form of separation of variables. Sir? Yes. So this would be 1/12 plus C. Well, but when you plug in 30 right here, after you do a natural log, but if your t is 0, but height is 30, now your natural log is going to be, or now your c is going to be the natural log of 20. Because this was not just like a variable that just went away or anything. Okay. In college, especially it's usually around after Cal 3, for those of you, because a lot of you guys are more math science people, could maybe take a class called differential equations. DiffQ, if you want to be cool, everybody calls it DiffQ. Okay, this is one type you'll do. Okay. The other type would be this guy right here. Then there's our lice minus licked type, our logistic type, and then there's like 6 others. Okay, so that you'll do. That's the whole class is doing 2 different variables and integrating them. You have exponential growth. So when do you use this guy? What does this look familiar to you? Remember? What was our little phrase for that one? Second? Okay, we called it second. Okay, that was what the y sub 0 is your constant. Now, when do you use this? The beginning of the summer, the population, rate proportional to the population. If you have a direct proportional thing going on, that's when you use this guy. Now, you could sit here and solve separation of variables, but this is where I said it's so much easier if you know the formula, make the jump. So the jump would be y equals your initial e to the kt from a population of 10 on May 1st. So 10 is my initial condition, e to the kt. So you would need to get the k value here to be able to work anything it tells you to do. So what do you use to find the k value? Okay, this 50 and this 30. Okay, there's 2 numbers, but which one is which? Okay, so this is your t, and this is your 50, which is your y. So then you would need to find k to be able to finish the problem. Okay, you got that? That's exponential. I would plug in 50 here. I would, yes, you have to divide by 10. So you would divide by 10, natural log both sides. Oh, yep, that's okay. Just kidding. Ooh, I'm awesome today. Okay. All right, moving on. There's a multiple choice question for you. Okay. The last thing I want to talk about was logistic, just so you can kind of see all three types and have something to review. Do you remember logistic? Remember the little picture of the cow and the tongue? Lice minus licked? Where is that coming from? Lice minus licked. Okay, if that helps you, maybe. But it's definitely, okay, so this is on your little yellow sheet, formula sheet, but you just had to remember it. Okay, so they're not hard, you just have to remember the formula. So that's exponential, and then this is logistic. So you have the population of bears is given by this equation right here. What about the carrying capacity? Remember that? Okay. What out of this formula do you remember was the carrying capacity? L. So L was the carrying capacity, which kind of means what in, say, a problem like this? Maximum population. Okay, so question A says, what's the carrying capacity for bears? 100. They could not have more than 100 bears in order to continue life for the bears. All right, what is the bear population when it's growing the fastest? Do you remember when the bear population is growing the fastest? Half of that, so it's growing the fastest at 50. So, okay. And then what is the rate of change of population when it's growing the fastest? Into where? Okay, so you would need to find you have dPdt, and you would just need to plug in 50 into that. Okay, that's yours, sir. It's common, yes. Now this particular question was nice because you didn't even really need to go put it into this form to do anything, right? Okay. Now they do all three forms. They do the factored, the unfactored, and then that guy right there. So like on the next one, I gave it to you unfactored, and I just wanted to say, all right, how do you factor it so that it's in the form that you want? So if you look at this right here, you need that variable to always be single for all of this formula to work out. So what would you, I mean, because otherwise you might be like, oh, I'm going to factor out a 2. No, you don't want to factor out a 2. Okay, you want that last thing to be just like a y or a p. So you're going to factor out 0.002p. And yeah, they probably would expect you to do this in your head. What's 0.002p out of 2? 1,000? Remember our multiplying by 10s from middle school? Like all of a sudden, 1,000? That's where our calculator dependence has come in handy, right? All right. Yes, yes, yes. Okay, let's say, how would you write the equation here? This is lice minus licked, so what would this be? 1,000 plus. Now you don't know C, so I'm going to leave C. But on logistic, that's not always going to be the initial condition. You have to solve for it. It's the void. Hello? Oh, that is a good question. On a situation like up here, like on this guy, then yes, that would have been your C. But it is not, that does not make, C is not defined as our initial condition for logistics. Because if you keep going here, you've got 1 plus C e to the negative Okay, so you need all those numbers, right? Okay, so what is the variables? You need, it's negative L, K, T. So what is your L? And your K, 0.002, and when you multiply those, that's negative 2 P. Because if you plug in 0 and 24 and go to, 0, I think it's the 24 is the, and there's 24 is what C ends up being, okay? But if you plug in 0 and 40 here and 0 here, you have to solve it to get that C value. Okay. Yes?
So can you take another shortcut if you're like, if you're given it in the unfactored form, and you just take the negative and the value for like a singular T, T?
Yes. Yes, that's all, yeah.
So like the exponent, the e to the negative 2t, you just going to put negative and whatever you put on the single t in the given.
He's saying, is that going to be your number there? Yeah, that's what he's saying, right? Yeah.
That will always work if it's not
If,
Because you have to do that math anyways, right? Because you're going to have to divide. You're going to have to divide out the 0.2.
I don't see why it wouldn't. Yeah. Yeah. Okay, questions for me? Okay, so, all right, did y'all, this was 24. Did y'all establish that?
Yeah.
Okay, so,
You plug in 40 p and then 0, 2,
there was a question on the mock that once you got your answer, it asked for the limit as it went to infinity. Okay, and I think all 2 people got it right who took the mock. But you had to get part A right in order to do part B, so that was part of it. Some people who didn't get the separation right. But how do you do a limit? This is a limit to the infinities, right? Okay, so if you do a limit to the infinities, you can use your idea of clowns. Well, if you use your idea of clowns, then isn't this really this? So a limit to the infinity, what's going to happen to that? That's going to go towards 0, and so 1 plus 0 is 1, so that would be 1,000. Okay, but doesn't that make sense because of the okay, isn't that going to be the carrying capacity? Okay, so that's fine and dandy, but so that makes sense on this one because we had an application for it. But yes, to do limits to the infinity, that's what you could have done for that one.
Will the limit be always in the carrying capacity?
For this situation, yes.
Like if you reckon for all on all logistic ones, if you recognize L as carrying capacity, does that make sense like an animal?
Yeah,
like
yeah.
As long as I recognize L as carrying capacity.
Yes, that is always going to be the case.
Will there ever be a point that requires me to show